turning tool movement given. Here, the right or left hand tool will perform the operations. Here we make different type of turning like square, beveled, filleted, and square. Then next operations, facing. Facings is the operations to reduce the length of the workpieces. Here the tool moves perpendicular to the lathe axis. In this lathe facing drawings, so facing tool is given and end of the workpiece is machining operations done to reduce the length of the workpieces. Then next operations, chamfering. So chamfering is the process of beveling the workpieces edges. So it also sometimes for removing burrs and sharpness. And one more operations in the lathe, knurling. So knurling is the process of making impressions on the surfaces of the workpiece by a special multi-point tools. Here in this drawing, chamfering and knurling tool is given. Then next one, forming. So forming is a process of making concave or convex or any irregular shape on the workpiece using form tool. And next one, grooving. It is a process of reducing diameter of the workpiece. It's also called recessing, undercutting, or negging. Then next one, parting off. So it is a process of cutting the workpiece into two halfway. So here the parting of tool. So here the left side chuck and right side workpieces. Now the workpieces is parting off into two way. Then next operations, eccentric turning. So it is a process of special turning process, that is it is used in manufacturing of camshaft and crankshaft. Then next operations, drilling. So for making an axial hole in the workpieces, the drill bit is mounted on the tailstock. It is given in this figure. So here the three jaw chuck and tailstock. It is connected in the tailstock. Drill bit is attached. So it is make the hole in the workpieces. It is the drilling operations. It is drilling also separate. It is also make in the drilling machines. It is also possible in the lathe operations. Small drilling operations made in the lathe operations. Then next one, reaming. So it's performed on the drilled hole, already drilled hole for removing burrs, burr. It is a polishing process of fine finishing process. In this reaming, special tool is used. This as the reaming tool. Then next one, boring operations. So it is used to enlarge the diameter of the already drilled hole. Here the tool is mounted on the bar. Then next operations in the lathe, milling. So here the work is mounted on the compound wrist with the clamp, and the multi-point cutter is mounted in the headstock. And next operations, grinding. Here a special grinding wheel is mounted parallel to the lathe bed. This kind of process is used to make recessing, polishing works. Then next one, tapping. So it is a process of making internal threads using a multi-point tool called tap. So making the in this drawing, it is here the work pieces. This is the tap tool. Here the tool rotations and feed directions. Here make the threads in the internal way using multi-point tool. The next one, thread cutting to produce helical groove in the cylindrical workpieces. That is called as the thread cutting. Here, the job is held between the centers and the tool is automatically feed longitudinally by using lock nut and lead screw arrangements. Depend upon the pitch to be cut on the workpiece. The required speed can be altered by using change the gears. In the teeth calculations formula, driver teeth divided by driven teeth equal to teeth on spindle gear divided by teeth on lead screw gear, that is equal to pitch to be cut on the work divided by pitch of lead screw. Driver teeth divided by driven teeth equal to pitch of the work divided by pitch of the lead screw. The next one, external thread cutting. The job is turned to the required diameter and it is held between the centers. Then the required speed is chosen by using calculations. Now the lead screw is rotated 1/4 of the spindle speed. Now the lock nut is enhanced for automatic movement of carriage. After one helical cut, the tool is adjusted to required depth. This is done for getting the required shape of thread as required. Next operations and last one, taper turning operations. Taper turning is a uniform change in the diameter of the workpieces measured along its length. That is, it is a process of making conical surface along the cylindrical workpiece. Here, capital D is the large diameter of the taper, small d is the small diameter of the taper, and the L is the length of the tapered part, and capital A is the off taper angle. Then conicity is calculated. K is equal to capital D minus small d divided by L. Here, different type of taper turning methods available. First one, form tool method, and second one, tailstock set over method, and third one, compound rest method, and fourth one, taper turning attachment method. In the form tool method, it is one of the simplest method of producing small taper in the workpieces. Here, the tool is ground to the required angle, then the tool is fed perpendicular to the workpieces. Now, lot of vibrations to machines tool and high force is required for these operations, and also low speed machining can be minimized the problem. Here the images for the form tool method. Here the form tool attached in this process. This is the image for the tailstock set over method. Here the face plate on the lathe top, and here the taper tool attached, and tool is attached, and dead center is there. In this tailstock set over method is offset to some required angle. Here set over H is equal to capital D divided by small d divided by 2L into capital L equal to L into tan alpha. Angle is the small, that is sin alpha equal to tan alpha. Here D is the maximum diameter of the workpieces, small d is the minimum diameter of the workpieces, L is required length on which taper being made, and capital L equal to full length of the workpieces. This method is applied when the taper angle is less than 80 degree. Here the workpiece is held between the centers and the tailstock is shifted from the lathe axis by adjusting the screws. It is called as tailstock set over. This kind of method is for long and less tapered jobs. Then next one, compound wrist method. This is for doing steep and short workpieces. Here, the compound wrist is tilted up to 45 degrees. This method is used for producing both internal and also external tapers. The next one, taper turning attachment method. This attachment is placed on the rear bed with bracket. This arrangement and swelled to a maximum angle of 10 degree on either side. Guide block connected to rear end of the cross slide. When the division is given in millimeter instead of degree, then the angular distance, then in terms of millimeter of the guide bar to be tilted is given by S equal to capital D minus small d divided by 2L into LG. LG is the half of the total length of the guide bar. S is the number of divisions in millimeter. That's all.